Here is your instruction for Lesson 9-2. Lesson 9-2 is about line of best fit. Very oftentimes when we have a bunch of data, it does not fit exactly on a line. The slope is not exact. Each point is not exactly 1 unit and 2 units from the next point, etc. So we look for a line of best fit. When data are collected, the points graph usually do not form a straight line, but may approximate a linear relationship. A line of best fit is a line that is very close to most of the data points. Remember, it's most of the data points. Number 1, refer to the information in the table about the cost of cookies. Construct a scatter plot using the data, then draw and assess a line that seems to best represent the data. So again, if you think about this, the price of cookies is not going to go up exactly 10 cents or 12 cents or 14 cents or whatever it is every single year. The prices are going to vary from year to year. So the data is going to look more like this, where you have data points that kind of seem to go up and down, etc., depending on the economy, that sort of thing. So this is a perfect representation of the concept that I was talking about. So in each case, we're going to graph each of the data points, and then we're going to draw a line that best fits the data. And here's a key part of that. About half of the data points are above the line and half of the points are below the line. Judge the closeness of the data points to the line. Most of the points are close to the line. So we could draw this data line, or this line right through the data points right here, and as they say, you can see that there's 4 above and there's 5 below. Another thing that you should take into consideration is if each of these points below is further away from the line than each of these points, then you probably should shift your line down a little bit. So in other words, basically you want to consider 2 things: the number of points above and below, and also the distance from the line above or below, and get that line as close to the center of that graph as you can. And problem number 2, they tell us, use the line of best fit to make a conjecture about the cost of cookies in 2013. So basically we just extend the line so that we can estimate the Y value for a value of 2013, or in other words, at 13 on our chart up above. You'll have to take a look in your book for that. The Y value for 13 is about $3.35. Therefore, we can predict that chocolate chip cookies would cost about $3.35 in 2013. And that's basically the reason that we make scatter plots. Please press pause and do letters A and B. I will give you a hint here. You can take a look at this data point here, and I think that you should all recognize that that is an outlier, and therefore you should pretty much ignore that when drawing your line of best fit. Refer to these pieces of data only. Problem number 3. The scatter plot shows the number of cellular service subscribers in the United States. Write an equation in slope-intercept form for the line of best fit that is drawn, and interpret the slope and the y-intercept. So what we're going to do is you can choose any 2 points, and I like the fact that they chose 3 and 9, and this is the reason. If you look at 3, we have a really nice intersection here. We can read both directions. We can see that we're exactly at 3 and that we're exactly at 150 here. And then at 9, we can see we're exactly at 9 and exactly at 275. So it makes it easy. We have 9 minus 3, of course, is going to give us our denominator of 6, and then 275 minus 150 is going to give us our numerator of 125, and that comes out to be about 20.83. So we can write an equation of y equals 20.83 is our slope, 20.83x, and it's plus, it looks to be right about 85 there, and if you look in your book, you'll see, if you scroll down, you will see that. So once we have that equation, that is our equation of the line, and then we could use that to find any value. Let's say we wanted to see this at 20, we would just put 20 in here and we would find that value there, and we'll show you that now. So again, here's our equation of y equals 20.83x plus 85, and in problem 4 they ask us to make a conjecture about the number of cellular subscribers in 2015. Now remember, it was years after 1999, so 2015 would represent 16 years after that. We have to put that value right in here. 20.83 times 16 is 418.25, and of course our intercept of 85, we would have there would be about 418.28 million cellular subscribers in the year 2015. Please press pause and do letters C and D.